All right, thanks so much. So I have the extreme pleasure of getting to lead NVIDIA's data center business for our automotive industry specifically. And so we're in a unique position. Hopefully most of you know what we're doing in the space. While it's not our intention to literally bring a self-driving car to market, you won't see us selling vehicles, we're doing everything that's required to bring self-driving cars to the road. So we have our own data collection fleets, we're building the artificial intelligence and deploying that in our customers' vehicles. And so what I'm going to spend my time today sharing with you is the key takeaways and our experiences and what we're seeing along the journey and some of the challenges that we're seeing as we build out those end-to-end needs. Now, before I get into that part of the story, just a few words. The good fortune of the gaming business, which I presume many of you in the room, and I've got a 14-year-old gamer who's quite happy that I'm in Nvidia. The gaming industry is important for what I'm going to talk about today for two reasons. One is our success in that industry is what has allowed us to pour literally billions of dollars into the work that we're doing around self-driving cars. But secondly, the work that we're doing in gaming is also fueling what I'm going to talk to you about in terms of what we're doing around simulation and testing in this space for artificial intelligence. Because AI is clearly going to be at the center of transforming the $10 trillion industry, and as you pointed out this morning, smart mobility is really going to change, and autonomous vehicles are going to have a huge impact on that industry as well. So a few words about what we think of as the 5 pillars of needs in this space. So years and years ago, when we got started with our first data collection car, the Nvidia BB8, it only had 5 cameras on it at the time, and they were arguably, compared to today's world, fairly low quality cameras, just 2 megapixel cameras. But with it taking 30 frames per second and the number of seconds in an hour, it doesn't take long to realize that based upon the 2,000 hours we were driving, we generated 1 billion images in just that first year with just one vehicle. And we actually converted those 1 billion images into 3 million labeled images that we then began our work developing the AI on. At that point in time, 10 deep neural networks. And this is a really complex challenge and has been going on for us for years. Throughout the presentation, I'll comment on some things, and I'll just start with the punchline now, which is, quite frankly, if you're a company that has made the decision that instead of asking NVIDIA to build the AI for you, that you're going to build the AI to meet your level 3 or level 4 or level 5 driving, and you don't already have the computational scale that I'm going to talk about throughout this presentation, and you haven't already collected enough data to have millions of images, there is no way you will meet your SOP. There are many of our clients that have stated we're going to have level 3 by 2020, and I'm telling you today, based on our own experience, if you haven't already deeply started the journey, we're not going to make those timelines. Now, the good news is we're, of course, here because we're helping the industry make the right investments to figure out the right scale and how to meet those needs. And then, of course, simulation, and as we call it, re-simulation, or you may think of it as verification, you may think of it as regression testing. Simulation is where we will look at taking advantage of photorealistic simulation, which sounds a lot like gaming and rendering that you might have from some of the advancements that we've made in this space. And so we see an opportunity to simulate every single global driving condition. We think that there could be as many as 100 million different global driving scenarios that need to be simulated and therefore tested. And then the other piece to this is we've got these data collection cars on the road. We have 20 or more of our own. We've got some of our clients that have hundreds that are on the road. Well, how do we take that data that we collected when we were simply collecting it to label it to then use for the AI? And how do we replay that data back through to see what would have happened if at that point in time when I was just collecting data, I actually had the AI running? So that's what we mean by resimulation. And then mapping is certainly a big challenge for the industry to face as well. So what we're hard at work is providing the GPU accelerated computing, the actual AI software itself, and in the cases of customers who come to us to build it for them, we're actually developing the deep neural networks. And so to give you a sense for some of that, the first challenge that we uncovered is that to do this well, we had to build something for ourselves that we call our Nvidia perception infrastructure, which is a tool that deals with the ingestion, the curation, the annotation, ultimately feeds the manual labeling work that I'm going to talk about that we're doing, as well as the active learning work that we're doing to be able to build AI that can actually label these images down the road as well. And we needed to have something that could provide the traceability and the auditability, and that could create these data sets, some of which we're using to do the training on our AI supercomputers, the DGX, which one of the speakers yesterday referenced, as well as the test data that we'll use both to validate and verify the AI that we're building, but also to be able to run the simulation in the resimulation for us. And then, of course, in our case, we're not just building AI supercomputers to use in the data center. We're building the system on chip, drive Pegasus, as you see listed here, so that AI can run inference and propel, of course, those autonomous vehicles. I talked about how when we were at the early days with just one vehicle, we were generating 1 billion images, that at that point in time, we labeled 3 million of them. So a brief word about some of that. Now, first of all, if you consider that 2 megapixel camera is roughly 2 megabytes, roughly translated, and I'm doing some CEO math, that was 2 petabytes for just that one vehicle. Again, we've got customers of ours that have 50 to 100, so they're generating hundreds of petabytes of data per year. And so there's folks from storage in the room that are quite excited about this, and there's some real challenges in where the cloud comes in, and there were some discussions yesterday around that, where we have to have both warm and cold storage for how we're going to store that data and have traceability. If it's 1 billion images for just one car, and we've got fleets of cars, then we're going to have billions of images. But the reality is, not all of that data is going to be useful to label and eventually have in our AI. And it's for a variety of reasons. I'm local, I live here, and I'm soon looking forward to snow again. And so we've got some cameras that are just going to have snow on the lens that will not make the data useful. But the other piece is if I'm doing highway driving and I'm driving straight for a long period of time, unlike the urban scenario that you presented this morning, we need to label a great many of the images for urban to make sure that we're seeing every scenario. When I'm driving straight on a highway for hours at a time, I don't need all those scenes to be able to have good understanding of the space. So that's why 20 to 50% of the data we're just going to throw away. And I say throw away loosely and softly, but it's not useful. In our case, we actually have 1,500 labelers in India and China that have a labeling capacity of roughly 1 million images a month. We've been at this for years. It's going to take somewhere in the neighborhood of 20 to 30 million labeled images, and the industry is still figuring out exactly how many, but on that order of magnitude. Labeled images, not the billions generated from the collection cars, labeled ones. And so we've invested heavily to get there and to get there quickly because our customers are asking us to. Now, we think somewhere in the neighborhood of 10 or more deep neural networks will be required for level 3, on the order of magnitude of 20 or more to be able to get to the full level 5 robotaxi. And we're deep at work developing all of those. Now, sometimes our customers will ask me, yeah, but what about fusion? Well, sure, we may eventually fuse some of these models, but we're going to have to build them independently in the beginning before we can eventually fuse them. So to give you a sense for the challenge, it's not just about collecting the data, training the models, tuning them, and deploying them on test fleets, which we do, but it's extremely iterative. And some of you in the room, I think, are very familiar with this, but we've got 1,400 people that are hard at work on this problem in NVIDIA. So if you think about the order of magnitude of the size of company we are, 2,000 engineers are focused on the problem, 1,400 are focused on the AI side, 600 focused on the hardware side, and 1,500 labelers. Is it the core? I said we're investing billions. This is the core of what we're doing. This is a challenging space. And for us, we go through an iterative process of exploration where we're just looking at the data to see what's useful and effectively building the first model and just seeing if it'll run. And then ultimately we'll do development, and we'll look at many different techniques, many different layers, and we will have tens, if not as many as 50 parallel experiments running. Now we have the benefit of having a Saturn V supercomputer that has 1,000 DGX-1s in it, so we can do that, but we'll have many of these jobs running at any given time so we can ultimately select. And then we've got to deploy that AI not just in the vehicles on the road, but in simulation and testing. So it's an extremely complex space. We have the extreme benefit when we work with our clients of knowing when we had this amount of data and we were working on this many DNNs, exactly how many DGX-1s on our Saturn V supercomputer we were consuming. And so the real benefit for us is that we can work with our clients and understand what's the data capacity that you have right now, what are the deep neural networks that you're using, what is the average size of the images that you're using for each one. We can provide coaching and guidance in terms of the number of images from our own work that we think our clients need to do. And it can be on the order of magnitude of 1 million images for the less complex ones to object detection. We're seeing in the order of magnitude of 6 million to 8 million images that we're using in that development. So as you could imagine, our point of view, of course, is this is a GPU-only problem. Because we are consuming hundreds of DGX-1s in a Saturn V supercomputer to get the work done. And we know the industry is going to need to consume that level of scale as well. This room probably has a good feeling for some of the AI, but just to give you a video sense for what we're developing for outside the vehicle, we're looking at perception models with things like object detection, everything from vehicles to passengers, et cetera. The inverse of that, free space detection. We're looking at distance for super level 2 type driving, lane and path keeping, mapping. There's 5 or more deep neural networks that we're developing. Other things that we as humans do really well, weight perception. Anyone ever had to think about, is that vehicle going to stop at the stop sign or not? Well, when we're in a world where we're going to have some actual humans driving and smart vehicles driving, we're going to have weight perception. So this gives you a sense of how we think there's at least 10 or more deep neural networks for even level 3 driving. And then our customers are having a really exciting time thinking about infotainment, intelligent experiences, and even distracted drivers. So how could we identify that someone is looking at their phone? How could we identify, even if someone has sunglasses on, Janine is wearing sunglasses here actually, that she's making movements that would tell us that she's a drowsy driver or actually closing her eyes, and we can actually develop AI to be able to identify these types of things. Or guardian angel type programs, and we're going to show you 2 views of that. One is keep the driver from opening the door when, in fact, a cyclist is approaching. The other is an example of weight perception. This driver didn't actually see that there was a vehicle coming. And so actually have the AI stop the vehicle from actually accelerating. So there's also terrific opportunities, and several of our clients are using this same AI in vehicle. I'm not at liberty to share who, but I can kind of tease out a little bit of the work that we're seeing. The real opportunity, there's multiple opportunities in this space, but there's a very interesting opportunity around smart mobility, and that's around monetizing travel time. And so how do we actually use AI to monetize travel time? And how do I use always listening and always watching AI, facial recognition, speech recognition, lip reading? How do I actually communicate with the passengers of that self-driving vehicle using that same AI that we're building for distracted driver to actually be able to recognize when we served an ad up to them how they reacted to it? We even have one client who's using the cameras outside the vehicle to be able to identify when they put an ad on the outside of the vehicle, did you look at it or not when it's going down the road? So some very, very exciting opportunities for AI in this space, and this is just another view that you'll have as a takeaway. And Drive AV is our brand term for the things that are outside the vehicle, and a summary, not all, but a summary of the AI. And Drive AX gets at intelligent experience, the kind of things inside the vehicle to spot both distracted drivers, drowsy drivers, and to eventually monetize travel time as well. And there's an awful lot of challenges I haven't even hinted at yet, like where are the lines on the roads, on the ones on the left? How do I know where to drive in that environment? Of course, a cyclist approaching like that is quick. I mentioned gesture detection in terms of the inside the vehicle, spotting someone that's looking at their phone, reaching in their purse, making a gesture of that kind. What is one of the hardest problems a self-driving vehicle is going to have? And there are many. There's a red light above me. I'm the traffic police, and I'm saying, come. What do? I'm a self-driving vehicle. We still have a mix of humans on the road and self-driving vehicles, and there's a red light over my head, and yet I'm directing traffic and I'm telling you to come. What do you do if you're a self-driving vehicle? That's going to be a really difficult problem to solve, as well as, what do I do when an ambulance is approaching? So if you haven't already gotten a sense that this is a really challenging work, also I hope you're picking up a sense that it's pretty exciting for us. It's our life's work, really, is how we think about it. So a brief word about simulation and testing. And then I've kind of built this to allow for ample time for Q&A. There's a variety of different reports that are out there. We have our own point of view that I'll share a little bit about. But then also we'll look to one third-party reference source. I don't know how many in the room are familiar with it. But Rand has laid out one outline that would suggest that in order for the AI to be 20% better than humans, and in this particular case it's pointing to reduce fatalities, that you would need to be able to drive and have that AI deployed and driven for 11 billion miles in order for it to be 20% better than human driving. Now, it doesn't take too much math to figure out 100 vehicles driving all the time would take over 500 years. Personally, I'll be way long gone, and all of us in the room will be, so this just isn't a viable solution. Now, I'm also going to tell you hardware in the loop is the only way to perfectly know that the AI is going to work well. So software in the loop is exciting, and we're going to provide those kind of capabilities to the industry. But we also need a mix of software in the loop simulation with real hardware in the loop testing too. And both have to be done. But simulation's absolutely a necessity because we just can't road test our way to safety. We just can't road test our way to safety by itself. And of course, it's all around the socioeconomic benefits, and safety is going to vary. We're seeing client to client, very different views on what safety means to them. But clearly, everyone has to solve it. So mostly I've been talking about our experiences. I will briefly delve into what we're building from one product standpoint because it's a problem we're seeing the industry is really struggling with. So I want to take a few minutes just to explain how we're approaching the simulation and testing problem. We've developed something we call Nvidia Drive Sim and Constellation. So Drive Sim is our software that will generate these rare and difficult conditions. It's the virtual reality AV simulator. And so what we will do is we will have GPUs that will cover every sensor that you would normally have in a vehicle. And so it'll be cameras, but also radar, LiDAR, and basically think of it as a GPU for every sensor that you might have, generating this photorealistic simulation of a real world from a company that knows a thing or two about rendering. And if you haven't read about, and you're interested in this space and you haven't read about our recent release around rendering, I would very much encourage you because movies in the future, we won't need us anymore. We can actually just render us to look just like us. So we're going to use that same capability to create all these different scenarios with one computer that's doing the photorealistic simulation. We'll then take a second computer and we'll take that Drive Pegasus, which is our current version of our system on chip. It's about the size of a license plate that's in the back of your vehicle to actually run the AI. We're going to actually put that in a second computer and we'll harden it and we'll treat it as if it's in the vehicle. So this second computer, it thinks, because it's the very in-vehicle hardware that you normally have in the back of the car. It thinks it's in the back of the car, but it's not. It's sitting in the simulated environment, and 30 times a second, the two computers are talking to each other. And so in this way, we're actually running all of the testing as if that vehicle's on the road, and we can effectively simulate all these different driving conditions. And this is what we mean by hardware in the loop. Now, you can use our AI supercomputers to have that drive sim photorealistic simulation run, and you can have it run at faster than normal clock speeds, and you can replay data to do software in the loop to see would that have worked well. But we would tell you, and we'll give very clear guidance, if you aren't doing the testing on the in-vehicle hardware, there can be, minor as they may be, there can be minor differences between software in the loop testing, which isn't the exact same in-vehicle hardware, in the in-vehicle hardware. So we strongly provide guidance to all of our clients that you have to do both. So just to give you a little bit of a sense of how this works, I think we all understand the concept, but we'll just show you a brief video here. You're going to see all the different angles of the sun, so watch closely and you'll see we're simulating all the different shadows and what you could potentially see. You know, sensors are critically important, so how do we actually simulate all the various different type of sensor conditions that we might have and get a real world. You're getting a bit of a sense, and this is actually before our most recent ray tracing. Here we're seeing the two different views to it, the real world and then actually the simulated environment and how they're very, of course, look very similar. So this gives you a sense for why our clients are saying it's quite exciting. And then you might have the oddest corner cases in the world that you don't even want to program the simulator to do, so just have a human actually do some crazy stunt in the simulator, and you don't even have to go through the act of programming it. And in this case, he's acting like he's driving a gaming car, but in the simulator, it's actually doing everything he was. And then we want to look at daytime, nighttime, and so the video will run for a little bit, but I mean, the whole idea, as this is finishing, and I said 100 million scenarios, is that we think of it as, first of all, there'll be roughly 100 normal driving scenarios at least that we'd want to simulate. And then of those 100, we may have another 100 environmental conditions, rain, snow, sunlight, all the various different weather conditions. And then we might have 100 what we would call transient situations. An adversarial car tries to cut me off. Not normal driving conditions, similar but not normal. And then in the world of AI, a lot of times you just want to introduce faults in to see what would happen if a vehicle just appeared out of nowhere, a vehicle's in front of me, it just disappeared. Multiply out hundreds of each of them, and this is where you quickly get to, because you multiply it across every one. This is where you could quickly get to 100 million different scenarios that need to be tested. And why this is such a critically important process for us. So we think of this as there are very deep end-to-end needs. There's huge challenges on the ingestion, labeling, and storage of the data collection process. There's significant challenges. I've told you we have the luxury of being able to have a Saturn V with 1,000 DGX-1s in it that we can do our training on. Every automotive OEM, manufacturer, tier one, who's going to tackle this problem is going to need a supercomputer at some point in time to solve this work. It is literally hundreds of DGX-1s to be able to eventually build all the deep neural networks. Simulation's going to be key, and you've got to deploy it in vehicle. We're proud to have an awful lot of the industry that's already working with us across many different facets. So a few final concluding remarks. It's about solving for the end-to-end needs. A lot of our clients are at very different stages of maturity, and so we work with them to help guide them on where to go. Having a supercomputer is not something most automotive OEMs have thought about deploying. So a dense data center design is very critically important. And we've spent thousands of hours building a reference architecture platform. Nvidia won't literally build the data center for you, but what we're doing is providing a playbook to our customers for how they should, because we have our own. So we've built that kind of expertise together. We would also highly advise our clients that it isn't just about the cost of the box. It's not just about the hardware TCO. It's about the productivity savings. And not even mentioned on the slide, but I will posit my safe harbor, not NVIDIA's position, Norm's personal opinion. My personal opinion is these OEMs, for all the right reasons, have all put launch dates out of when they're going to have super level 2 or level 3 or level 4 or level 5 in market. Loyalty is roughly 50% in this industry. I would posit that consumers remember those announcement dates and are going to wait for the OEM that they feel the best about. But if they miss and they want a level 3 car, they're going somewhere else. And 1 percentage point of loyalty in this industry, if you're Ford, GM, Volkswagen, the top Toyota, the top tier, 1 percentage point of loyalty is $700 million. That's what's at stake of missing your dates. 1% of loyalty is $700 million. So how much the box costs, is that really the question? So I've left about 5 minutes for Q&A.
Questions?
There's someone in the back.
Hey there. On? Hello? Nope. That's where it is. Hey there.
No.
Still
Great.
not? No, it is. Eureka. It was great pitch. Interesting. I actually disagree with you on your last point, particularly given the first presentation this morning about kind of the general sentiment about self-driving. I actually think if OEMs miss their date and expose the fact that they're upping the level of safety and quality around these things, I actually think it'll drive better brand stickiness. I think that the more the OEMs and the community around it can kind of be a little bit transparent about the complexity of this problem, and the end goal is public safety on every level, and it's going to take what it's going to take. I think that does a service to the community about awareness and confidence in the solutions as they come out. If you're a buyer and someone says, I'm going to hit that date regardless, how will you feel about buying that car? I'm not going to buy that car. So I actually think the more we veer the other way, I think it does a great service. But excellent, fantastic, kind of really impressive what NVIDIA is doing.
Veer together, I agree, but I would just ask, but what if someone has met the highest levels of safety in the rest of the industry? Then they win. That's the point I'm really making.
I think I actually think the industry is going to kind of, I think there's almost like this collective experience. I think that it will be hard to imagine that one OEM would be that much further along than others. They're all watching each other. They're going to the same conferences. They're reading the same papers. They're playing with the same technology. I just think it's a hard problem.
Hi, Norm. First of all, thanks for the great presentation. And I've been a fan of following NVIDIA for many, many, many years. So you guys are doing great stuff. Two questions. One is, you seem to imply that the bulk of training data will be artificial. Because of the number of years that it'll take. In other words, the simulation data, there'll be more simulation images than real classified images training the network. Is that true?
No, and if you got that impression, I apologize.
Okay.
In fact,
we've had our customers, 518 years.
We've had our customers ask us, can we use the simulated data to build the AI off? And the answer is no.
Okay, so that's part one.
You need the hard work of labeled data to build the AI. Use the simulated environment to test every possible global driving condition.
So, okay, that's cool, because I think that there's still so much mystery as to actually how deep learning works in terms of not the performance of it, but how it actually learns, that mixing metaphors of real data and artificial data where there's stochastic scenery and things like that is kind of dangerous. So that was one point. The second point is, do you think that when we start to introduce cars with automated driving, that we have a completely new training task ahead of us, because the behavior of those vehicles is unlike that of human-operated vehicles.
And how will the humans respond to those
Exactly.
vehicles being on the road? Yes, we're going to have this challenge is going to go on and on and on, and absolutely we're going to see that, and we're going to have corner cases where a human responded in a way that we wouldn't have anticipated. Unfortunately, that.
So one question, and I know in the interest of time you couldn't cover everything NVIDIA is doing, but there's a lot of thought and papers written about what's going to be going on outside of the car. In other words, on the edge, IoT things, putting sensors that are more than just saying I'm a lamppost, but monitoring traffic, monitoring situations and that. Sure. Is NVIDIA doing much of that yet, or is that kind of a next phase?
Oh goodness, yeah. We're doing a ton of work around what we call intelligent video analytics. And so we already have the AI embedded in cameras around the world where we're able to spot someone that's snatched a purse, or it's actually been deployed in airports where we can watch people going through that have left a bag, to give you just a few examples. But oh yeah, we've got hundreds of partners actually in this space. We call it the AI City, and we're short on time, but if you just go look up AI City on nvidia.com, you can, and tons of videos actually to show the concept.
So 2 questions. Well, first, thanks a huge amount. The first is the model is that each car is going to do its own work. But we heard from Datora that there's a lot of sort of inter-vehicle potential for discussion, communication, intelligence sharing. So yep. How is that being incorporated into the model, the fabric, if you will? Second question is what's NVIDIA's business? You're selling boxes, compute hardware, but clearly you're building a huge infrastructure, a huge set of intellectual property. You seem to be saying to OEMs, well, this is what you got to do to be successful. I'm wondering if you're going to be a tier 2 supplier.
So I'll answer the second question first. And it's fairly transparent to the industry. So, of course, there's folks in the room, so I'm picking my words carefully to some degree, as you might imagine. But the industry understands they have 2 buying decisions they can make. On the in-vehicle side, you can take our system on chip, and then we have a software stack called Drive AV. That's for the clients that say, I can't get there on my own, you need to build the AI for me. And they'll enlist NVIDIA's help, and we'll scope how much AI work needs to be done, and we'll literally build the AI for them and deploy it to run in vehicle. And so we're monetizing the in-vehicle work in that way, including that distracted driver, all the AI that I showed you. And then on the data center side, we're monetizing it via our AI supercomputers, and we've built the software to ingest data. We've built deep learning frameworks to make it easy to deploy. And how much do you pay for those?
In the first scenario, will you take the liability?
It's an interesting question the industry, I would argue, doesn't know the answer to yet, is the way I'll address that for the time being. But the answer to my question about the software that we're building is we don't monetize the software. And this isn't magic to the industry. I think the industry knows it. So we make our money off the compute infrastructure. We invest billions in the software, and with our compute infrastructure, you get all the software we build.
Inter-vehicle communication and sharing of object identification.
I don't have the best answer, and I'm probably not the best person at NVIDIA to answer it. In that we've got a whole group of people that are spending all the time with all the sensor manufacturers, and in fact, investigating all that intelligent video analytics. It's not the world I own, and so I could give you a guess at a good answer, but it may not be the right one, so I prefer not to be wrong.
Any other questions? Norm, thank you very much.